What's so important about data? In this day and age, maintaining a healthy business goes hand in hand alongside working with data. Whether you understand it or not, there is no denying that data is at the foundation of any successful company, and the business entrepreneurs that are leading the way are aware that looking deeper into data is what will make them tower above the competition. Let's start with the data team, or the big data team. They will want to solve a business problem. The team will do a significant amount of work on the data that is available first. Based on that, the business intelligence team will provide a business insights dashboard. After the dashboard is ready, the data science team will use some business analytics or data analytics tools to develop models that could predict future outcomes. Hold the phone! What on earth are we talking about? Unless you are a data science whiz kid, you may think we're just picking words out of the dictionary and sticking them together at random. Nope. These are actual data science buzzwords, and not only that, there are many other similar phrases. No wonder you're confused. But fret not. It's completely understandable for you to feel like this. Let us shed some light as to how things became so complicated. One cause of this confusion is the constant evolution of the data science industry, and in turn, the meaning of these buzzwords. This complicates the situation a lot. For example, someone who had the title of statistician 25 years ago would have been responsible for gathering and cleaning data sets and applying various statistical methods to the data. After some years, however, with the growth of data and the radical improvement of technology, this statistician would now be required to extract patterns from data. Henceforth, a new buzzword was coined: data mining. Similarly, forward wind a few more years, and the same statistician, due to new mathematical and statistical models, could now perform more accurate forecasts. And again, another term has found its way into an already inflated business glossary: predictive analytics. Has the statistician changed her job by this point? Nope. Are her goals different? Nope, not really. However, she is more qualified now to be part of the statistics department, predictive analytics team, or have the title data scientist. Hopefully, it's easy to see now how these buzzwords develop over time and how someone who would qualify as a statistician 25 years ago and had kept up with modern technologies could fit into a multitude of professional categories now. Interesting, but a little messy, right? Another cause of confusion, which stems from the one just mentioned, comes from HR managers who, understandably, can become overwhelmed with the barrage of new terms and buzzwords flying around. This causes them to label job positions inaccurately, often seeming like they are choosing them on a whim. One HR representative may call a job position data analytics specialist when, in fact, they need a data analyst. Another may employ a junior data scientist when they require a business intelligence analyst. Of course, there are many companies that word their job offers brilliantly, but this is not standard across the board, which can cause even more of a mess. Now, as exemplified already, the world of data and data science can seem overwhelming and may very well make you want to run away and hide from anything data related. But bear with us a little longer. We, the 365 Data Science team, are here to help you sort through the clutter and see data science in a whole new, brighter, clearer light. We have designed a unique infographic to put everything together. Of course, you could search the internet for different glossaries, but why waste time? With us, you will find an aggregated, concise, and to-the-point structure containing all technical and business terms that are frequently used in the field of data science. We begin by clarifying the similarities and differences between the terms business analytics, data science, business intelligence, and machine learning. Then, we focus on helping you digest the definitions you need to know in an effective way. By the end, you will be more than capable of being able to relate and apply various expressions and buzzwords to the areas of data science they belong to. So, what are we waiting for? Let's dive straight in. Alright, so let's discuss the not-so-obvious differences between the terms analysis and analytics. Due to the similarity of the words, some people believe they share the same meaning and thus use them interchangeably. Technically, this isn't correct. There is, in fact, a distinct difference between the two. And the reason for one often being used instead of the other is the lack of a transparent understanding of both. So, let's clear this up, shall we? First, we will start with analysis. Consider the following. You have a huge data set containing data of various types. Instead of tackling the entire data and running the risk of becoming overwhelmed, you separate it into easier to digest chunks and study them individually and examine how they relate to other parts. And that's analysis in a nutshell. One important thing to remember, however, is that you perform analyses on things that have already happened in the past, such as using an analysis to explain how a story ended the way it did, or how there was a decrease in sales last summer. All this means that we do analyses to explain how and/or why something happened. Great! Now, this leads us nicely onto the definition of analytics. As you have probably guessed, analytics generally refers to the future. Instead of explaining past events, it explores potential future ones. Analytics is essentially the application of logical and computational reasoning to the component parts obtained in an analysis. And in doing this, you are looking for patterns and exploring what you could do with them in the future. Here, analytics branches off into two areas: qualitative analytics. This is using your intuition and experience in conjunction with the analysis to plan your next business move. And quantitative analytics. This is applying formulas and algorithms to numbers you have gathered from your analysis. Here are a couple of examples. Say you are an owner of an online clothing store. You are ahead of the competition and have a great understanding of what your customers' needs and wants are. You've performed a very detailed analysis from women's clothing articles and feel sure about which fashion trends to follow. You may use this intuition to decide on which styles of clothing to start selling. This would be qualitative analytics. But you might not know when to introduce the new collection. In that case, relying on past sales data and user experience data, you could predict in which month it would be best to do that. This is an example of using quantitative analytics. Fantastic! To backtrack a little, you can combine these areas with analyses also. You could perform qualitative analysis to explain how or why a story ended the way it did, and you can perform quantitative analysis, working with past data to explain how sales decreased last summer. Perfect! Now that we have cleared up the differences between analysis and analytics, it shouldn't be too difficult to see how terms such as data analysis, data analytics, business analysis, and business analytics can have their unique meanings too. More of this will be explained in the next video, which aims to simplify these as well as many more with a fantastic diagram. So, let's move on. Okay, so it's time for us to create a diagram that will shed light on the most popular disciplines in the data science field and how they all intertwine with each other. As you know, everything is not particularly clear-cut, but the following diagram will help untangle the knotty mess of activities in the data science and business realms. Hold on to your hats. Let's begin with a list of terms covering a few aspects of the business sphere. Business case studies, qualitative analytics, preliminary data report, reporting with visuals, creating dashboards, and sales forecasting. Don't panic. We will explain the meaning of each of these terms post-haste. First, though, take a moment to think what they all have in common. That's right. They are all part of the business world. We'll depict this with a blue rectangle here. Good. Now, let's think about the following. How many of these terms involve working with data? If we drew another rectangle and placed the activities for which it is essential to have data available in there, which ones, if any, would overlap with the business rectangle? The answer is some. That's because some business activities are data-driven, while others are subjective or experience-driven. Of course, there are disciplines that will overlap. We will place them in the common area of the two rectangles. So, let's see. Which of the subfields from our list represent a business activity involving data? Well, you'll need data to create a preliminary report. A visual representation of the performance of your company for last year. A business dashboard. And also a forecast for the future sales of your company. So, these four labels can sit comfortably in the overlapping area. Great! The other two terms, business case studies and qualitative analytics, get left behind, as they belong only to the sphere of business. They are not related to working with data. Let's explore why. Business case studies are real-world experiences of how business people and companies succeed or fail. You don't need a data set to learn from business cases. Thus, it will remain purely in the blue rectangle. Simple, right? The same can be said for qualitative analytics. As touched upon in the previous video, this is all about using your intuition and the knowledge of the market to help in the future planning process. Perfect! Things are becoming clearer already. Now would be the perfect time to introduce a timeline to our graph. The reason for doing that is that some of the terms you see refer to activities that aim to explain past behavior, while others refer to activities used for predicting future behavior. Let's cut the picture roughly through the middle. This line will represent the present. Okay, therefore, all terms that are on the right side of this line will regard analytics, future planning, and forecasting. And those that are on the left of the line will be related to the analysis of past events or data. Perfect! Business case studies examine events that have already happened. For instance, one could learn from them and attempt to prevent making a similar mistake in the future, right? As a result, we could say studying business cases is part of your analysis. So, this activity refers to the past. Hence, it must be located on the left of the vertical line on our graph. We will move it up slightly to be able to contrast it to the other business term, qualitative analytics. This includes working with tools that help predict future behavior, therefore must be placed on the right. Awesome! In essence, what we have now is qualitative analytics, which belongs to the area of business analytics, while learning from business case studies is part of your business analysis. However, this is not what many professionals would say. In practice, analytics has become a term comprising both analysis and analytics. Although this goes against what we explained earlier, please allow us to accept the industry jargon and leave business analytics as a label for the entire set of business processes you see on the graph. It may look like we're confusing matters, but things will be simpler in the long run. All right. Hopefully, we're starting to get our heads around many of these terms and where they fit with each other. So, what about the rest of the terms you see on the diagram? Well, preparing a report or a dashboard is always a reflection of past data. So, these terms will remain untouched. Forecasting, though, is a future-oriented activity. So, we can move it to the right of the black line, but not too much. It must still belong on the sphere of business, so it must be in the area where business analytics and data intersect. Great! Again, It is common practice to use the encompassing term data analytics to refer to both the analyses and analytics. While we know what the terms mean now, to keep things simple, following the standards of other business professionals is a good idea. Okay, good. Let's continue with adding another term, the most sparkly of them all, data science. Data science is a discipline reliant on data availability, while business analytics does not completely rely on data. However, data science incorporates part of data analytics, mostly the part that uses complex mathematical, statistical, and programming tools. Consequently, this green rectangle, representing data science on our diagram, will not overlap with data analytics completely, but it will reach a point beyond the area of business analytics. Okay, great. Does this mean that the preliminary data report, reporting with visuals, creating dashboards, and sales forecasting are of interest to a data scientist? Yes, absolutely. And now, do you think we can find an example of a discipline that belongs to the field of data science and is considered data analytics, but not business analytics? Well, think of the oil and gas industry and the optimization of drilling operations. This is a perfect fit for this sub-area. Data science can be used to improve the accuracy of predictions based on data extracted from various activities typical for drilling efficiency. And that certainly isn't business analytics. Great. What is left is to think of something that involves data analytics, but neither data science nor business analytics. Can we find an example here as well? Sure, digital signal processing would do the job. Digital signal is used to represent data in the form of discrete values, which is an example of numeric data. Therefore, data analytics can be applied to digital signal in order to produce a higher quality signal, and that's what digital signal processing is all about. Amazing! We hope the diagram is helping you to visualize how all the pieces fit together, because we're not done yet. We will continue with the remaining disciplines related to the world of business and data science in our next video. See you there! Okay, people, we have gone from a rather odd-looking design to what now is hopefully a comprehensive and easy-to-follow model. We say hopefully because we will be sticking to the same method of visualization as we proceed. Great! We know you're eager to see what comes next. We're going to add business intelligence to the diagram. But what is business intelligence, and how does it fit into the picture? Remember the following. Business intelligence, or BI, is the process of analyzing and reporting historical business data. After reports and dashboards have been prepared, they can be used to make informed strategic and tactical business decisions by end users, such as the general manager. Concisely put, business intelligence aims to explain past events using business data. So, with this information, we can work out where the business intelligence rectangle should go. It must go on the left of the timeline, as it deals only with past events, and it must sit within the data science rectangle as a subfield. Business intelligence fits comfortably within data science because it is the preliminary step of predictive analytics. It makes sense when you think about it. First, you must analyze past data and extract useful insights. Using these inferences will allow you to create appropriate models that could predict the future of your business accurately. Great! Let's move on. How should we distribute the three terms that remain over here? Preliminary data report is the first step of any data analysis. It can also be considered as data science, so this term can stay where it is. As with reporting and creating dashboards, these are precisely what business intelligence is all about. So, we will neatly place these two into the orange rectangle. Fantastic! And that's pretty much it for business intelligence. Now,
we delve into the controversial yet rapidly expanding field of artificial intelligence, AI, and its subfield, machine learning, ML. The ability of machines to predict outcomes without being explicitly programmed to do so is regarded as machine learning. Expanding on this, ML is about creating and implementing algorithms that let machines receive data and use this data to make predictions, analyze patterns, and give recommendations on their own. Machine learning cannot be implemented without data. Hence, it should stay within data analytics completely. This could be considered as a bold statement to make, as it is debatable whether this is correct. Some argue that data analytics and ML are two unrelated scientific fields. For the sake of argument, we will let the machine learning and data analytics rectangles overlap. And, in a moment, we will exemplify some areas that could be considered parts of both disciplines. Moreover, ML should expand slightly to the left of the vertical line. The reason for that is the increasing tendency towards applying machine learning tools to the context of business intelligence. Fantastic! You remember we mentioned artificial intelligence, right? By definition, it is about simulating human knowledge and decision-making with computers. It is quite a general term that can have a rather philosophical interpretation. We, as humans, have only managed to reach AI through machine learning, the discipline we just talked about. And, as data scientists, we are interested in how tools from machine learning can help us improve the accuracy of our estimations. AI is beyond our expertise. We have mentioned it just to avoid the confusion of where it stands relative to the other fields of interest. All right, let's provide a few examples. The demand for accurate, real-time dashboards opens space for machine learning applications. Machine learning software can pull data from third-party companies, such as Facebook or Shopify, detect new patterns from their data, and thus suggest real-time recommendations and insights to managers and other decision-makers. This is a great way to improve the performance of your business as soon as there is a chance to do so. In general, there is a lot of potential for development in this field. Turning to the other side of the vertical line, we can say client retention and acquisition are two typical business activities where machine learning is involved. It helps develop models that predict what a client's next purchase would be, for example. Since we could say data analytics and data science are applied in client retention and acquisition as well, we can leave this term right over here. Okay. ML can be applied to fraud prevention as another example. We can feed a machine learning algorithm with prior fraudulent activity data. It will find patterns which the human brain is incapable of seeing. Having a model which can detect such transactions or operations in real time has helped the financial system prevent a huge amount of fraudulent activity. These examples are probably not the first that would spring to mind when talking AI and ML. Usually, speech and image recognition are among the most popular examples, as they are already being implemented in products like Siri, Cortana, Google's Assistant, and more impressively, self-driving cars. Naturally, these two examples are outside the business context, and it is debatable whether they could be placed under the umbrella of data science, data analytics, both, or neither. As it is a hot topic for discussion right now, we think they are worth mentioning. However, to avoid further confusion and disputes, let's take speech and image recognition out of the picture. Finally, an example that is considered artificial intelligence, but not machine learning, is symbolic reasoning. It is based on the high-level human-readable representations of problems and logic. It was once a trend in the past when people were trying to create human-like intelligence. Today, though, machine learning is the only form of general artificial intelligence that is being applied, and symbolic AI is rarely encountered, let alone practiced. All right. So, along with speech and image recognition, we can remove symbolic AI from the equation also. This will leave us with only what we are interested in, Nice! Now, we would like to mention a term that has invaded almost all business and data science glossaries: advanced analytics. It is rather a marketing term, coming from people who want to say that the type of analytics they are dealing with is not easy to handle. This is a subjective way of looking at it. Often, intimidating sounding terms are used to discourage learning and create prestige. However, we are here to attempt to clarify the terms within analytics. And advanced analytics is technically a term that exists. So, we will collectively group all areas of analytics under advanced analytics, with the idea that any part of analytics can seem advanced at first, but that no part is exclusively or permanently within this category. Perfect! Remember that all areas intertwine, and what we show here is not a strict representation of commonly accepted meanings and definitions. It is all matter of interpretation, and this graph is our vision of data science. The locations of some of the components in the diagram are somewhat controversial. However, we believe this is a very comprehensive depiction of what these disciplines are about and how they overlap. Before we wrap up, the position and the size of the rectangles show conceptual similarities and differences, not complexity. All right, great. Finally, let's refer to our infographic. You won't need all fields from the diagram because we will be concentrating on data science and its application in business. Therefore, this is the rectangle that we will be working on next. The infographic I am talking about looks like this. It may look a little complicated at first, but if you follow us through the next videos, we will explain it step by step. Thank you for watching. Right, so how do you approach a business or a data science task? Here are two possible scenarios. Imagine your boss has carefully read the company's reports and dashboards and wants you to make some predictions for the firm's outgoing costs over the next year. The logical way to approach this problem is to gather some relevant data and then prepare it for analysis. Alternatively, your boss might come to you and say, "Hey, we have this enormous amount of data here. We don't really know what we could do with it. It's customer data, so it must be useful. Can you do something with it and tell us how we could increase our profit for next year?" In this case, having the data set is the starting point. Unlike the first case, you don't need to collect data that will help you answer a business question. You are provided with the data and off you go. You can analyze it and apply different analytical tools to extract insights and make forecasts. In either scenario, from a data scientist perspective, the solution to every task begins with having a proper data set. This must be first on your to-do list. Only then can you proceed with further analysis and forecasting. To combat the entire process of solving a business task, we have prepared our 365 Data Science infographic, a visual summary of all must-know data science terms and concepts. Now, it may look overcrowded, but we think it is the most concise and to-the-point representation of data science terms you will find. And it is one which you need to have under your belt before entering the field of data science. So, what's inside? Briefly, we have split the information into 5 columns, each detailing different stages of the process of solving a business task: working with traditional data or big data, doing business intelligence, applying traditional data science techniques, and using unconventional machine learning techniques. Then, we have divided the columns into rows, which contain the answers to the following questions. When is this part of the process applied? Why do we need it? What are the techniques related to this activity? Where or in which real-life cases can it be applied? How is it implemented? Using what tools? Who is doing this? What are the common misconceptions about this activity? The entire picture resembles a table or matrix, with 7 rows and 5 columns. Hopefully, when broken down like this, it looks a little less intimidating. Great! So, we can say this infographic is a companion to the diagram we already talked about. We are still looking at the areas where business and data science overlap, but we have structured the visualization in a slightly different way. Additionally, we have extended the picture with 2 columns containing data terms only. Now, starting from the next video, we will go through each part of the infographic step by step, and you will be able to compare the terms and buzzwords related to each discipline easily. Fantastic! This is everything we have to share with you about the structure of the infographic visualization. It is simple and intuitive, and it will clear all doubts you have. We can promise you that. So, in our next video, we will begin our presentation. Are you excited? Because we are. See you there.